9702 October November 2024, paper 4, variant 1, and the question number 8, which belongs to the section of quantum physics. A polished sheet of magnesium in a vacuum emits electron when it is illuminated by an ultraviolet radiation. Very simple. First, 1 mark. First question is state the name of this phenomena. Photoelectric effect, right? So, for the emission of electron to occur, the frequency of the ultraviolet radiation must be the least frequency 8.8 into 10 to the power 14 Hertz. Calculate the work function. So, it is the first formula of our quantum physics. So, work function equals Planck's constant into the minimum frequency or the threshold frequency. So 6.63 into 10 to the power minus 34 is the value, and 8.8 into 10 to the power 14 is given. So the work function will we have 5.83 into 10 to the power minus 19 joule. So as the values are in two significant figure, so it is 5.8 into 10 to the power minus 19 joule. For an ultraviolet radiation with a frequency of 11 into 10 to the power 14 Hertz, calculate the maximum speed of the emitted electrons. So, for any work function energy, the minimum plus the energy it possesses, kinetic energy, right? So, after substituting the known values like kinetic energy equals the maximum work function minus the minimum work function, so we will get it HF equals 6.63 into 10 to the power minus 34 into 11 into 10 to the power 14. So we will get 7.293 into 10 to the power minus 19. And in the previous part we already find out, right, which is 5.83 into 10 to the power minus 19. So the kinetic energy will be 7.29 minus 5.83 into 10 to the power minus 19. So what we get 1.46 into 10 to the power minus 19 joule. Now the question is the maximum speed. So we know the value of electron, the mass of the electron is 9.11 into 10 to the power minus 31. So after arranging this formula, so we got Vmax is equals to 1.46 into 10 to the power minus 19 multiplied by 2, and then it is divided by the mass, right, of the electron and making the root of it. So after putting the values, we got 5.66 into 10 to the power 5. So the answer for the two significant value, it will be 5.7 into 10 to the power 5 meter per second. The frequency of the ultraviolet radiation incident on the magnesium sheet is varied between 8 into 10 to the power 14 to 11 into 10 to the power 14 Hertz. So you need to make the sketch. Variation of frequency and the maximum kinetic energy, emitted electron. So they have already given the scale, right? So what we have here, the value is started from 8. Okay, now what we got so far is 5.8 is the minimum work function is 5.8 into 10 to the power minus 19, right? Threshold frequency is 8.8 into 10 to the power 14, and at that time there will be no kinetic energy maximum, right? So the kinetic energy at that time is 0. So, and for the last value we have given is 7.3 into 10 to the power minus 19 joule. The frequency is 11 into 10 to the power 14 Hertz, and the kinetic energy is gonna be 1.46 into 10 to the power minus 19 joule, right? So if we see the graph having the value of two significant value, right? So 8.8, so 8.8 should be we see it's 2, so it will be 8.6 over here, 8.7, and that is the 8.8. So this is your value 8.8. so we will mark it in the different color, so 6, 7 and 8. Now the next value is for 11 into 10 to the power 14 hertz, so it is 11 into 10 to the power 14, and we have 1 over here, so the value is 1.46. so if we see this, so it is what we have 1, so here it is 1, and then it's 1.1, 1.2, 1.3, 1.4, and that is 1.5, and the value is 1.46, so that will be 1.45. more or less it will be somehow here, just above the 1.46 value, right? So either we mark over here or over here, so we can do both. So what we are doing 46, so it will be around a little bit above than 1.45. so next thing is to get the line. So this is our gradient, so this should be a straight line, right, showing y equals mx plus c, a straight line, right? So we have done it and scored 9 marks.